Hey guys, this is Brad Dyke saying hi. I promised you guys 3 operations and related management videos and 2 hardware videos. So this is me doing the second part, the geek out part, where we get to play with hardware. Um, I've had quite a few of you guys ask a couple of questions about test stations and how can you effectively, really today, do a test station that will work. Well, I have your answer for you. So with that, I have some preparations here that I'm going to do real quick so that I have this all set and ready for you. And give me just a second while I reach over and grab 2 systems really quick. Okay, so when you work environments and you have so many different environment tools that you're working, for instance, you have an old platform or you found a eclectic machine that you loved when you one day worked in one lab or somewhere, or you had a great deal on hardware resources that you get your hands on in Google. By the way, I will not tell you how cheap some of this stuff was that I got, but it was cheap. But it also goes down to your test station. So what do I mean by the test station? So let me walk you through that. Now, if you look down here, and I'm going to turn this so you can see it. If you look down, you will see what we call a test station. This is a very, very easy, simple, open industry test platform. But what I was looking for were the holes that are mounted on the platform. Why? I'll explain. You see, the nature of how this will work is driven by the aspect of how well and how many different ways you can configure your station. Now, this has an add-on, which I put on. It's called a brick. It's designed to offer a mounting point for a power supply, but I have different generational power supply setups, or I could even build in a power stand for a power supply. Here I have these basic fitters, and these fitters are plastic. I bought them on Amazon for about $2 or $3, and they are added together and removed and adjusted as necessary in height and width so that I could mount a different class of motherboard based on the form factor of the motherboard. Now, what do I mean by form factor? Well, the very first thing about form factor is, we have what we call the ATX style footprint, which is right now what this is set for. And if I come over here, I can mount this right now on a raised bed, and there it is. It's ready to go. I can also mount small factor, and this is a small factor footprint right here. Very small logic board, but I could mount it on this same chassis. Why? Because the holes that I have here allow me to move my support frames, these are my support frames, around so I can have that device, board, whatever it may be, in here and in use. Now, another very valuable thing is this little guy. I got it off of a computer, a Dell computer, and it's basically an LED light up, a rocker switch, and that's actually not a rocker switch, it's a push button switch, and a power LED. And of course the responding outputs, because this is what gives me easy power on, power off functionality when I bring motherboards into the environment. But that's not the only thing that I work with here. I also have cable management. I have different class changers so that I could use a single style monitor and keyboard and mouse, which would transcend most platforms. But I also have down in my trusty little box hole PS2 keyboards and mice as well. That allows me to go to legacy, which I do every once in a while do. And so with that being said, I also have mounting screw sets, and this is by choice, but I like the finger-driven screws that make it very easy to mount and dismount because over time it adds up. But then you also want the anchor screws that are designed for such as an L bracket stack or something like that. And what do I mean by an L bracket stack or a footprint stack? Is I'm referring to one of these. So this is an L bracket slot that fills up the back hole. It's also the same mounting tip that is used on a video card. And the video card will usually in some cases have 2 mounting points, as you can see here on this ATI GeForce. And this guy right here is one I use for this workbench, to be exact. Then I have specialized, and these are just basically L brackets that I've cut up, and then just with a drill press, mounted my own anchoring points. So if I wanted to do something special, or I wanted to add an additional reinforcement, I can do that by putting a bolt nut in this, mounting it in place, and it allows me to adjust my footprint for testing on the fly. Now, another thing which is very valuable is you have your DVD or Blu-ray device, which is USB driven, which is really good because most boards come with a USB 1.0 or better. I do also have available for Linux environments or rapid boots. I have my NVMe environment drive, but I also principally just use a standard SSD 148 gig low-cost boot OS drive like this one. And these are all around in pieces and parts on the bench so that I can do the tagging and configuration. Now, with that being put in place, and I'll go ahead and put this back on, the next thing is power. And that's the one thing you see here missing, right? So I do have a power box here. And this one is quite powerful. Actually, it's overkill. But it is a 1,000 watt power supply. The reason why it's so powerful is because I will build cryptic engines from point to point. And that would require multiple video cards that are separate from the motherboard using USB bridge cabling to PCIe daughter cards. And then here you can see my step brake coming in and providing the proper anchoring points for the power supply so it's in place. But this power supply is highly specialized. It has the connector edges, but you know, just a simple $50 power supply will do you justice. That doesn't have to be this complicated. But it is a very good functional power supply because I've got so many different heads that can do so many different configurations for power output that it makes it really easy to, you know, hook up a drive, as you see here, run the SATA cable over, and boom, it's operational. So, with that being the case, now you take a step back and you look at the environment. You need Cat5 connectivity for either local or for testing diagnostic cards like network cards and so on. This is my PCI 1 network test card board. So I would test a lot of different cards which are PCIe 1 class. And but I would also test it on the 8-bit by 16-bit as well, so that I could, you know, do as many as I could and confirm that the hardware is good. Maybe an HBA, a controller for discs or whatever. This motherboard will also actually support 6 video cards, 2 on the PCIe extendeds, these two guys right here, which this is the full bandwidth, this is the half bandwidth, and then these guys individually. But for GPU encryption and coining cryptocurrency, geez, I can't talk, that is overkill. You don't really need that kind of bandwidth. You're just principally just using the standard 4x style bandwidth channel for doing your processing. That's the sad part about GPU processing, is it really doesn't use much bandwidth wise. With that being said, this is a fairly advanced motherboard too, because it can do NVMe, SATA bridging, and RAID configurations as well. That would be, of course, different if we were looking at this kind of a form factor, or if I was going to put that god-awful, almost a PC machine into use, which is such a proprietary base board that no ATX standard test case can test it, but this one can. Or if it's as big as a Dell Inspiron 2800. These are powerful, wonderful boxes with dual processors and all that. They can mount in this case by raising the restrictor bar, this guy right here, and they kind of go off the board a little bit, but they are also very mountable because the bevel edge is away from the actual edge of the front frame, so that helps a lot. So all in all, with this cute little 1, 2, 3 video, I thought you guys would get a kick out of this and enjoy this, as you would see it as a very cheap, efficient way of owning or handling your own design board. Now, I almost made my own. I just basically went out and bought an Intact test workbench. That's what this would be called, or a PC motherboard test workbench. And then just drill the extra holes and thread out the threadings I need for the standoffs. With that being said, I found this board. I liked it. They don't make it anymore, so I don't have a link to give you guys, but I just give you the idea and the value behind it. And this is a GPU cryptocurrency stand. This particular version is not a typical PC bench, but the PC benches are pretty doggone awesome too. And the one thing I do like about the PC benches that this does not offer is it'll have a subsection underneath, which you can use for for funneling cabling and things like that, and it will stand up about 4 or 5 inches higher than this one is now, which of course we do have a lot of cable management challenges with that, which we deal with because of the flat format. But the flat format's so easy, the light hits it just right, so it's easy to read. It's overall very easy to work with. You get all of your cables that you need, all your extenders if you need them. These are fan extenders. You can set up pathways for your CPU vanning. And you can also, one other very important detail I have found immensely valuable is to have surface mounts, double-sided tape. Really works. It's really nice to have it. Careful with the 3M. You use it, you're not taking it off. But if you use the foam version, double-sided, works pretty good. Velcro, as you can see here, I have as well when I need them, but that's usually to hold a hard drive or something like that below the tray. That's another reason why I raised the motherboard, so I could slip stuff under here, such as a DVD-ROM drive or something like that, just to get them out of the way. But with that being the case, you're going to have a system that's going to be fairly flexible. You have all the parts and pieces you need. I even keep a bundle of wire ties, so if I want to really keep things restricted, you can actually repurpose these wire ties, bound up a SATA cable in a tight formation like this, and getting that cable under control is as much of a pain in the butt as using the cable itself. And you just untie it all, you put them back in their little bins, and you bring the next piece of hardware out. And this is how you can reveal a lot of hardware in a day or two, opposed to having to tear each machine one tower apart at a time and try to do testing based on their flexibility of fitting. So with that being the case, the next thing I'll talk to you is when you design your test lab environments to do your software testing that would sit on your multiplexing environments such as Proxmox or VMware or whatever you want to use, sitting on your infrastructure, doing what you need it to do. The key detail here is remember that how you build your diagnostics and walkthrough stations is equally as important to accessibility. And I have that actual setup here. I have the middle bench for diagnosis. I have the R&D bench, which is over here, which does research on the internet. I have the console environment sets over here, which are KVM'd into all of the devices you see over here. And of course, the infrastructure, the way that is set up, HVAC and all of that. So we'll talk to that in the next hardware video. All right, take care. God bless.